Good afternoon, Year 5. It's Wednesday, the 10th of February. Today's science lesson is to understand gravity. Okay, first of all, just to look at some key vocabulary that we've already looked at throughout the course of this topic. Okay, so we've looked at air resistance when you were making your parachutes. I know we didn't do any experiments linked to water resistance, but it acts in the same way as air resistance, in the same way as friction does. Okay, so the experiment where you were using how far something would travel depending on the surface, another keyword, whether that friction was rough or smooth, and the effect that had on the distance travelled. So we've got some other keywords here as well. Accelerate. If you accelerate, it's starting to speed up. The opposite of that would be decelerate, so decreasing in speed. We've also looked at this person in our science topic, Galileo Galilei. He was the inventor of the telescope and looking at the different theories around the Earth not being flat. Okay, we looked at that last term. So some words today, hopefully that's some new vocabulary that we're going to look at, is a scientist called Isaac Newton. And we will also be looking at the effect, and what that has on movement. Okay, and also, very importantly today, the theory of gravitation. Okay, what do forces do? Have a chat with the person sitting next to you, or have a think by yourself if you're at home, or if you've got an adult or a sibling kicking around. See if you could say, what do forces do? What do they do to objects? What do they do? So they make things move faster, move slower, or change direction. Okay, depending on either the contact made to the object, making it move, or sometimes the object may move even by non-contact. Also, it may change shape. Okay. On this slide, just thinking about the different forces here, we've got big and little forces. You can see the force of the wind there, the air resistance, the balloon, that idea of changing. Okay, this slide, gravity in action. Some astronauts in zero gravity conditions. So here I've got a link all about weightlessness, okay, and how the lack of gravity in the air creates that weightlessness. A zero gravity flight, which also explains it as well. So what I would like you to do is just pause the video and go and watch these two links about weightlessness in space and Brian Cox experiencing zero gravity. Okay, what do you think? Why do you think the people in the plane and the space shuttle were able to float in the air? And why can we not do this in our classroom? And why, if I drop the book falls to the floor instead of floating in the air? What are some of the reasons there? So when we think about gravity, the gravity of the Earth's pull pulling everything to the center of the Earth, we have that weight of our bodies as well, meaning that we don't float, and the weight of the book forcing that to the ground there through the act of gravity. Okay, let's think back through our history of when the theory of gravity was first realized. So the following historical explanations that people had before Isaac Newton began to explain gravity correctly in 1666. So the ancient Greece thought that objects fell because they were trying to find their natural places. Scientist Johannes Kepler, who showed that the planets moved in an elliptical rather than a circular motion, still thought that there was some invisible framework supporting them. So Newton showed us that instead there was this invisible force called gravity acting on all objects, including us, all of the time. and explains that because gravity is a force, it can be cancelled out, and that this is what happens in the weightless flight. That an object needs to be massive to have a gravitational pull that we notice. Okay. I wonder if you can think about what piece of fruit you think about when you think of Isaac Newton. Have a think. Hopefully you thought it was apple. Okay, so the story goes that Newton was sitting under a tree and an apple fell from the tree and it started to give this idea of gravity, this idea of that invisible force pulling everything of weight downward. Okay, so I mentioned yesterday in our Zoom meeting that for today's lesson you might need a Malteser, a straw if possible, or some kind of small tube. If you could go and get that, that would be great, or a ping pong. There are some ping pongs in school that the children in school could use, and some straws as well. Okay, so how could you make an object move without touching it, without physically touching it? Hopefully you can think of some ideas here. So here we've got a little representation here of the straw and the ping pong, using the ping pong, that upward force without contact. The ping pong falling, the arrow represents the force of gravity. So remember, gravity pulling downwards all the time. The ball does not fall when your sucking force equals the gravity. So the weight pulling down on the ping pong, if that is equaled by the sucking force of the sucking through the straw, the ping pong or the Malteser should stay where it is. Okay, meaning that it is balanced. So which diagram, shows the sucking force equal to the force of gravity here? Look carefully at the arrows. Which force is stronger? The ball does not fall when your upward force is equal to the force of gravity, and you can see there the arrows are showing that equal force. Okay, gravity in action. This is another video clip for you to go and watch, which will show you how the balloon in action. Okay, on this side I've got a ping pong ball and a marble. You'll be able to see it very, very slightly there. And I want you to try and make a prediction about which one will reach the bottom first. You'll notice where they have hit the floor and then come back up is the same each time. So here, when it's hit the ground, sorry, just need to get a highlighter. When it's hit the ground there, then where it bounced is the same each time. Okay, that's not where it's released, that's where it left the hand at the top. It bounced, came back up, bounced again, came back up to that second point there, third, fourth, and then at the bottom there, finally landing. So, which one do you think would reach the ground first if they're dropped at the same time? The two objects are released at the same time. As they fall, the light flashes at a steady rate. For each flash, the positions of the objects are shown at the same moment. The pictures show that the ping pong ball and the marble fall at almost the same rate. The marble actually reaches the ground first. This is because there is air resistance slowing the larger object down more than the smaller object. So the resistance of the air, and because the ping pong ball is larger and has a larger surface area, it hits the ground a little bit slower than the marble. Here we've got another example of objects being dropped at the same rate. So we've got a heavy geological hammer and a falcon feather were dropped from the same height. They hit the lunar space surface at the same time. So I want you to, there's a link here, just here. If you click on that link, it should take you to that video there to show you that. All of these links, boys and girls, I will save at the bottom of the YouTube channel as the YouTube video as well, if you are watching it at home. Conduct your own experiments by dropping different weighted objects. Make a prediction about which one you think will land first. Remember what you've learned about where the objects that dropped at the same height, regardless of their weight, would land at the same time, okay? Especially if their surface area is around the same. You've got an information text to read, and then you've got to answer the questions and upload those to Teams. When you get the question sheet, you will notice that there is a set of questions on page 1, and then on page 2, it always gives you the start of your response to the question, and then you just have to fill in the next part. There are some extension questions there, which I really like to see some boys and girls get onto. If when you're conducting your own experiments, you might want to take a picture or explain the objects that you dropped and what the result of that was. Okay, looking forward to seeing that work, boys and girls. Well done.